Okay, to continue our discussion of functions, we're going to talk about the graph of functions. So a graph of a function is a graph of all of its ordered pairs. Just like with a line that we talked about at the beginning of the semester, except for this, we don't necessarily have to have a straight line. So given a graph, we can use the vertical line test to check if the graph represents a function. So what the vertical line test says is if any vertical line we draw intersects, meaning crosses or touches the graph in more than one point, then the graph does not define y as a function of x. So let's take the one on the left. And it doesn't matter. Okay, pretend these are good straight vertical lines. You guys know I can't draw. But anywhere I draw a vertical line, it doesn't matter. Anywhere. It only touches the graph once. So this passes the vertical line test, so it is a function. Moving on to the next one. Well, let's see. If I draw a line here, it hits the graph twice. If I do it here, oh golly, that hits 4 times. If I do it here, it hits 4 times. And it doesn't matter that I drew 3 lines. As soon as one line touches the graph, one vertical line, touches the graph more than one time, then it's not a function. So this one's not a function. Now, why does the vertical line test work? The vertical line test works because if you think about it, let's see. Whoops. Let me erase what I have on this graph. And let's see. Trying to pick a place. Well, I don't really have 2 good points. So I take that back. Let's go back to this other one. Let me get rid of all these points. So if I draw a line here, this is the point it crosses, right? And that point is 2, -2. Now, just for the sake of argument for a minute, pretend that I also had this piece of function. And so it also crosses the graph here at the point 2, 2. Now, what's the problem with this? We said last time when we were talking about section 8.1 that each input can only have one output. But here, you see, once I drew in the other piece of the graph, that vertical line touches twice with the same input and different outputs. So that's why it would not be a function. Now, we're not changing the answer because I just drew this to illustrate a point. So we're going to get rid of that part and go back to all the vertical lines we had. All right. So let's go back to domain and range. When we talked about domain and range in 8.1, we talked about the domain as all the first coordinates in all the ordered pairs. And we talked about the range as the second set of all the coordinates in the ordered pairs. So graphs are still relations. So we can find a domain by referring to the x values, and we can find the range by referring to the y values. So most graphs have an infinite number of ordered pairs. So because of that, we're going to use interval notation to describe the domain and the range. We'll only use the roster method. So that was back in section 8.1 when we were writing the sets for domain and range close to the beginning. We'll only use that when the domain or range has a finite number of values. So we'll see what that means in a minute. So I just want to reiterate here, the domain is all the x values. So if we highlight on the x-axis where the graph starts to where it stops, that will tell us our domain. Similarly, if we highlight on the y-axis from the lowest point of the graph to the highest point of the graph, that will tell us what our range is. And remember, when we use interval notation, it's always smallest number on the left and largest number on the right. And the other thing we have to remember is that this or this includes the endpoint. And the two parentheses, those do not include the endpoints. Okay, so looking at the domain and range here, does this graph, do you think, contain an infinite or finite number of values? I'll give you a hint. Anytime you don't see distinct separate dots, it's infinite. So this one's infinite. Remember, infinite means we use interval notation. So what is our domain? So the domain here, we need to put the x values. So where does it start looking from left to right? We should start at the left. Well, it goes all the way here. Whoops, that might be a little large. And it starts here and goes all the way across. Now, these arrows here means that it keeps going, the graph keeps going this way forever. So that means our domain also keeps going both directions forever. So that means negative infinity to infinity. And remember, infinities, we can never include them, so parentheses. Now let's look at the range. The range here is also infinite. And that means we should use interval notation. So let's look at the values on the y-axis. So going from bottom to top, it starts here, and the highest the graph gets is at 2. But remember, on the two sides, it keeps going down forever. So that means that our range keeps going down forever. So remember, smallest number first. So starting at the bottom, we have a negative infinity. And then it goes all the way up to 2. Now we know we can't include infinity or negative infinity, so that has to be a parentheses. What about at the 2 end? Well, up here you can see that it can equal 2 because right there is a point where the y value is 2. So that means we should have a bracket. So negative infinity with a parentheses, comma 2, close bracket. I mean square bracket. All right, let's look at the next one. The next one, our domain, contains a finite number of values because these are separate points. So that means we need to use the roster method. So using the roster method, we need to find every x value. Whoops. I forgot to color code our range up here. Okay, so doing the domain, let's, on the x-axis, highlight every value. So we have this one, this one, this one, this one, and that one. So we will just list them. We have -4, -2, 0, 2, and 5. So remember our domain is blue. Let's go to our range in green. So for the range, we need to go on the y-axis and just highlight how high it is. So all of these points happen to be at the same height, which is 4. So our range is just 4. Again, this is finite, and we should use the roster method because there's only one value. All right, let's try this one, which is a little bit more complicated. So this one is also infinite, which means we should use interval notation. And I know you're probably wondering how it's infinite when it doesn't go forever in any direction. Well, there are an infinite number of points along this line no matter what, whether it goes forever in both directions or not. So let's do our domain. So starting at the left, what's the furthest left it goes? Well, that's at the 2. And we keep going right until we get to the other side of the x values, which is at that open dot. Now, open dot means not included, so that's a parentheses. And closed dot means included, so that's a bracket. So in interval notation, we have an x value with a bracket at -2, stretching all the way to -1, but not including -1, so we use the parentheses. Okay, doing the range, remember, we need to go from the lowest vertical distance to the highest. So the lowest vertical distance is here, and we go up, and we're keeping up, going up, going up, going up, going up, till we get to right there. Now this one, remember, at the top has a closed point, so that is a square bracket. And at the bottom, there's actually a point there, so that is also a square bracket. So our range is the smallest value, which is vertical value, which is 1. Sorry, I hate when I keep accidentally hitting things. I don't mean to. And our largest y value is 5, also included. So we have the closed interval from 1 to 5. Okay, moving on. So on this one, we should have an arrow right here. For our domain, is it finite or infinite? Also, we should have a point right there. Okay, this one, hopefully you said is infinite because it's not just a bunch of random points. So we should use interval notation for our domain. So going on the x values, we have from here where this point is, keep going, keep going, keep going till we hit the end. But remember, there's an arrow, so it keeps going forever. Now, remember, at the back end, it is closed because we actually have a point there. So that point at the left side, we know it's closed, and it's at -6 for an x value. And the x values keep going all the way to infinity, which always gets a parentheses. Now let's do the range. So on the range, we have an infinite number of values, which means we should use interval notation. And let's see what that looks like. So going vertically, the smallest is right here at 0. Well, over there, but at 0. And it keeps going up. And because of this arrow, it keeps going up and up and up and up and up forever. So smallest value first is -5. Largest value, not -5, sorry, 0, because we're looking vertically. That was good. And there is a bracket at 0 because there's actually a point whose y value is 0. And of course, infinity always gets a parenthesis. Okay, so the other thing we can do with a graph of a function is answer some questions about it, other than just domain and range. So let's do that, and we'll be done with 8.2. So, excuse me, domain, remember, is all the possible x values. So this should keep going that way, and it keeps going that way. Sorry about not having those arrows on there. So, x values, well, it starts all the way at the left of the graph and goes all the way across to the right. I know it doesn't look like it, but remember down here, it keeps going that way, so it keeps getting wider forever. So arrows on both sides. That means we have -infinity to infinity with parentheses on both sides. All right, now let's think about the range. So starting at the bottom, the range starts here, because we're right here. It goes up, it goes up, it goes up, it goes up. It goes up, it goes up, it goes up, past here even because this is the highest point. So we're going to go all the way up to 4. Now, of course, we can see it keeps going down forever at the lower end because of the arrow. And at the top, we should have a bracket because it can actually equal 4 at the very tippy top of that curved part. So our range, starting at the bottom, is negative infinity. It goes up to 4, parenthesis on the negative infinity side, and bracket on the 4 end. All right, now let's talk about evaluating. So before, when we had an equation and it asked us what f of 5 was, we just, or negative 5, sorry, we just plugged negative 5 in for x and crunched numbers, right? Well, we don't have an equation this time. But what this says to us is find y when x equals negative 5. So where is x negative 5? X is negative 5 right here. And we're just going to go vertically, since we're looking for a y value, until we hit the graph. So right here is where we hit the graph. Sorry, that is not the color I wanted. And the coordinates of that point are negative 5, negative 5. Remember x and then y. So when x is negative 5, y happens to also be negative 5. All right, on part D, it's flipped. So this one says find x when y is 3. So to do that one, we go to y equals 3, 1, 2, 3. And since we're looking for x, we're going to go horizontally until we hit the graph. Well, there's one point here, and there's a second point there. So there are 2 values of x when y equals 3. X could be 0, or x could be 2. At what points does the graph cross the x-axis? So remember, x-axis is, well, I'm trying to find a decent color here. Guess we'll try that one. X-axis is this one. So where does it cross? At this point and this point. So those points are negative 1, 0, and 3, 0. Okay, where does the graph cross the y-axis? Well, it crosses the y-axis right here on top of that purple spot. So it crosses the y-axis at the point 0, 3. Now it wants to know for what values of x is f of x less than 0. So this is asking us, where is the graph below the x-axis? And instead of saying where, well, let me leave that, where. We're actually looking for x values where the graph is below the x-axis. So let's highlight that. I'm going to do it in, I don't know, let's go with Pepto-Bismol pink here. So below the x-axis, well, this piece is below the x-axis, right? All the way forever. And so is this piece. Forever. Now, do we include those two purplish dots that are on the x-axis? And the answer is no, because on the x-axis is not... Oh, bad me. I did below. Sorry, we were supposed to do above. Above. So undo all that pink. My bad. This is what happens when you work. When you work too many hours. Okay, so above the x-axis. Let's try this again. Here's above the x-axis. Do we include those points on the x-axis? Again, no, because they're on the x-axis, not above. So we have a parentheses here and a parentheses there. Now, the thing is, we always give these in terms of x values. So the x value here on the left side is -1, and the x value on the right side is a 3. And since we can't include the points on the axis, we have to use parentheses. Okay, and the last one says, is f of 15 positive or negative? So this is asking us when x is 15, is y positive or negative? Well, the problem is 15 is somewhere off the edge of the graph, right? But what do we know? We know that our x value, as it gets bigger, y keeps getting smaller from this point on, and it's already well below the x-axis. So it has to be negative. All right, in the next video, we are going to pick up with 11.3, which is all about quadratic functions. So all those ax squared plus bx plus c's we've been talking about solving, we're going to learn how to graph those and do other things with them.